Hello students! So my plan is that while we're together during Zoom, we would go over these warm-up problems together and practice finding domain and range. Now if you weren't there so you didn't see it, or if I forgot to do it, then you should watch this part of the video. But if you were there and I did it, then you can just fast forward to the beginning of the notes. Okay, so if we're going to find the domain, we need to remember that for a square root function, domain and range, of course, always have to be real numbers, and so for a square root function, we need the inside of the radical to be greater than or equal to 0. So for number 1, the domain is going to be x is greater than or equal to 0. And then think about the range. If you take the square root of something that's 0 or greater, you're going to get a number that is 0 or greater. Now what we see in most of the following examples are transformations where we are shifting this graph left or right, and so that's going to shift the domain but not the range. So what we see in number 2 is the square root of x minus 1. So we need x minus 1 to be greater than or equal to 0, which means that x has to be greater than or equal to 1. So that means the domain is x is greater than or equal to 1, and the range is still y is greater than or equal to 0. Now we can also use intervals for these. So for example, from number 1, we could have the interval from 0 to infinity on both of these, and we would have a closed bracket on 0 showing that we're including it. So number 3 is like number 2. We can say that x minus 2 has to be greater than or equal to 0, so x is greater than or equal to 2, so that's our domain. Now I can see how for these easier ones, you don't necessarily need to write out the algebra. The first thing I would do if I'm doing it mentally is I would ask myself, what value of x makes the inside of the radical 0? And so for number 3, that would be x equals 2. And then I would ask myself, should I have numbers that are greater than 2 or less than 2? And you can test some either way and figure out which direction you want to go. So the same would apply for number 4. So what number would make the inside of the radical 0? Well, that would be the number k. And then do I want numbers greater than k or less than k? Well, if I want the inside of the radical to be positive, then I need numbers greater than k. So it's going to be x is greater than or equal to k. That's the domain. And the range is still y is greater than or equal to 0. Now for number 5 and 6, I switch things around a little bit. So not only do we have a shift, but we have some kind of reflection, and we're not that familiar with it, so it might be wise just to go back to making an inequality. 1 minus x is greater than or equal to 0, so the opposite of x is greater than or equal to negative 1, so x is less than or equal to 1. Remember, if you divide by a negative, you have to reverse the sign. So that's our domain, and then our range is going to be y is greater than or equal to 0 again. So same idea for number 6. We have 2 minus x is greater than or equal to 0. So the opposite of x is greater than or equal to negative 2, and x is less than or equal to 2. That's the domain. Range is y is greater than or equal to 0. Number 7 I'm going to come back to in a minute. Let's go ahead and do 8, 9, and 10. So if you think about what we previously learned about the cube root function, and even if you want to picture it, you have something kind of like this. Remember, the domain is all real numbers, and the range is all real numbers. Well, if you shift it 1 to the right, or k to the left and the right depending on, or the right depending on the value of k, you're going to just still have all real numbers for your domain and your range. Okay, let's go back to number 7. Y equals the square root of 1 minus x squared. If we think about it algebraically, it's still that we need 1 minus x squared to be greater than or equal to 0. Now let's think about this, and let's think about something we did back in chapter 4. This is a quadratic inequality. Remember, to solve a quadratic inequality is not as simple as solving a linear inequality. We need the critical point method. Oops, hard to talk and spell at the same time. Inequity. I'm getting there. Inequality. There we go. So this needs the critical point method. So remember that method. First, start by setting it equal to 0 so that you can find your critical points. It turns out this is factorable. So let's factor it, and let's set each factor equal to 0 and solve each of these. And we end up with x equals 1 or x equals -1. Those are the critical points. Use those to divide the number line into intervals. And then we're going to take a test point in each interval. Let's test x equals -2, x equals 0, and x equals 2. We'll test those numbers into the factors, and we'll see whether we get something greater than or equal to 0 or not. So if we take -2, put it in the first factor, we have a positive. Put it in the second factor, we have a negative. Positive times negative is negative. The second one, we're going to get a positive times a positive. And the third one, we're going to get a negative times a positive. So we want greater than 0, so we want positive. So we want this middle interval, and we want equal to 0, so we're going to include the endpoints. And the way we could write that using an inequality is -1 is less than or equal to x is less than or equal to 1. Now there's a chance that you would have found that answer for the domain even if you were not doing it algebraically, if you were just thinking it through. For the range, we still know that the values of y have to be positive, but it actually turns out that this is the graph of half a circle. The largest the y values can be is 1. When x is 0, we have the square root of 1, which is 1. And so the range is values from 0 to 1. So 0 is less than or equal to y is less than or equal to 1. Okay, so that takes us through the warm-up. And the topic for today is going to be solving radical equations. Some of the equations are in radical form, like you see in number 1. Some of them are in rational exponent form, but either way, it's the same idea. And this is notes number 34. So I believe I'm still recording, but something happened to my record button and I can't find it. So that's why I'm kind of paused right now, because I want to pause and I can't find what happened to that part of my box. There we go. Okay, sorry about that, but we are back in business. Notes number 34, solving radical equations. Okay, number 1. I'm sure it makes sense to you that to undo a square root, you need to square. So what we're going to do for this equation is we're going to square both sides. You just need to know that when you square a side, you square the entire quantity. You don't square individual parts. And that should make sense for this problem, but I'm going to need to remind you about that on future problems. Sometimes people don't do the exact order of operations like they should. So this is going to be 5x minus 9 equals 121. And then we can add 9 to both sides and divide by 5. Looks like that's going to be, what, 26? Does that look right? Okay. Number 2. The directions are different, but really this is the same kind of problem as number 1. Find x. Remember in number 1 we solved for x. Find x when h of x is 7. So we can just put 7 in for h of x, and now we have an equation that looks pretty much like number 1 did. So what we're going to do is square both sides, and that gives us 49 equals 64 minus x squared. I'm going to add x squared to both sides and subtract 49 from both sides. That gives me 15, right? 64, my brain does not want to add and subtract right now. Okay, and then we're going to square root. So we have plus or minus square root 15. Whoops, look at that. Let me make that an x. Okay, there we go. Number 3. Now, my computer didn't let me type this problem in a very easy to read way, but the 3/5 that you're seeing here, that is an exponent. Okay, so 7, 7x to the 3/5. But it's not 7x to the 3/5. It's not that. 7 is not part of the base. It's just 7 times x to the 3/5. So the first thing we should do is divide both sides by 7. Now, how do we undo a 3/5 power? Well, let's think about some of our exponent properties. So what power could we raise this to so that we just had x? Or in other words, so that we just had x to the first. So 3/5 times what would be 1. And of course that would be 3/5 times its reciprocal, and the reciprocal of 3/5 is 5/3. So if we raise it to the 5/3 power, we just end up with x to the first. So then on the other side, we're going to raise it to the 5/3 power as well. Okay, so that means we have x equals 8 to the 5/3. Now remember, we can think of that as 8 to the 1/3 power to the 5th, and we know that 8 to the 1/3 power is the same as the cube root of 8, and that is 2. And 2 to the 5th power is 32. So x equals 32. Okay, number 4. The 2/3 is an exponent, by the way. So first, let's isolate this part, because we need to isolate the part that's raised to a power before we take a root, just like we did on number 3. So we're going to add 9 to both sides. X minus 4 to the 2/3 power equals 25. Now, we're going to miss something important if we do exactly what we did on number 3. So if we do what we did on number 3, we would raise both sides to the 3/2 power. That seems logical. What's wrong with that? Doesn't seem like there's anything. But we just have to remember that the 1/2 power is the same thing as a square root, right? And when you square root both sides of an equation, you're supposed to put plus or minus. So that means I'm going to have x minus 4 equals plus or minus 25 to the 3/2. I'm going to start with 25 to the 1/2 power, which is the square root of 25, and then after I get that number, I'll cube it. So we have plus or minus 5 cubed. So we have plus or minus 125. And then we're going to add 4 to both of those. So 4 plus 125 is 129, and 4 minus 125 is negative 121. Okay. Number 5 is similar to the last couple problems where we have an exponent, a rational exponent, but we need to isolate that part before we raise both sides to a power. So let's subtract 3 from both sides. And then let's raise both sides to what power? What would you say? What's going to undo the 1/3 power? That's right, cubing. So we'll cube both sides. And now we have x plus 4 equals 4 cubed, and 4 cubed is 64. So we have x equals 60. And then number 6 is where things start to get a little bit more complicated, because as you see, we have x in multiple places in the equation. This is where there is a chance that we could be introducing extraneous solutions, because we know that this part has to work out to be positive. But depending on what x is, there's a likelihood that this part might not be positive. And if that happens, we're going to have an extraneous solution. So we're going to check for that when we get to the end of the problem. For now, let's square both sides. And we have x minus 6 equals, now look, we're squaring the side, right? We're squaring the quantity x minus 8. That means we're multiplying x minus 8 by itself. We're not just squaring the x and squaring the 8. Remember, I told you in the beginning, it's not just square the parts, it's square the whole side. So that's going to be x squared minus 16x plus 64. Now we have a quadratic equation. So how about if I get everything over to one side? It doesn't really matter which. So I'm just going to get everything over to the right, since most of the terms were already there. And then if it factors, that's great. If not, we'll use the quadratic formula. Turns out that this does factor. So we'll set each factor equal to 0 and solve each one. And we have x equals 10 or x equals 7. Okay, remember, now we need to go back and see if both of these answers actually work. So I'm going to make use of this extra space over here and do a check. Let's check x equals 10. So plug it into the original equation. Square root of 10 minus 6 equals 10 minus 8. Square root of 10 minus 6 would be the square root of 4, and the square root of 4 is 2. Let's check x equals 7. The square root of 7 minus 6 equals 7 minus 8. Square root of 1 is not negative 1. Some people get confused on this because they think, wait a minute, when I square root, don't I put plus or minus? But remember, the radical sign, which was given in the original problem and we're carrying through, the radical sign means the principal root. The principal root is the positive one. So x equals 7 is extraneous, so our only answer is x equals 10. Okay, we have two last examples, and we're going to check for extraneous solutions again, but these are even more complex. Because notice that not only do we have x in multiple places, but we have two radicals. The same concept applies, it's just going to be more detailed work. Square both sides. When you square the left, you just have x plus 6. But when you square the right, you actually have to FOIL, so I'm going to write out what we're about to do. Square root 11 minus x minus 3 times square root 11 minus x minus 3. Okay, so when we multiply that all out, the first will give us 11 minus x. The outside, negative 3 times square root blah blah blah. The inside, negative 3 times square root blah blah blah. Together we have negative 6 times square root blah blah blah. And the outside, or excuse me, the last is plus 9. So believe it or not, we've made progress because we now have an equation with one radical, not an equation with two. And what we can do is simplify by moving all of the terms that are not the radical term to one side of the equation and leaving the radical term on the other side. So I'm going to add x to both sides of the equation, and I'm going to subtract 20 from both sides of the equation. Now, because we still have a square root in the equation, we're going to square both sides. And we could do that now, and that would be fine. Or if we want to make things easier on ourselves, we can simplify the equation first. So I would simplify the equation by dividing both sides by 2. Now, a lot of people would say they just want to divide both sides by negative 6. That does simplify the right, but it makes the left more complicated because now you're going to have fractions on the left, and now you're going to have to FOIL something with fractions in it. So I don't think that's going to be better. I think if we just divide both sides by 2, it's going to make both sides simpler, but neither side more complicated. Okay, so now we're going to square both sides, square the whole side, square the whole side. Now on the left, we're FOILing, right? So we have x squared minus 14x plus 49. On the right, it's not the FOIL process, it's a product. It's negative 3 times the square root, and to square a product, you square each factor. Square the negative 3, you get 9. Square the square root, you get 11 minus x. We can distribute the 9. And then, once again, like in the last problem, we have a quadratic equation. So let's get everything over to one side, add 9x to both sides, and subtract 99 from both sides. And it looks like this one is going to be factorable, x minus 10 times x plus 5. Set each factor equal to 0, and solve each one. And we end up with x equals 10, or x equals negative 5. So let's go way back to the beginning, and let's check for extraneous solutions. So let's check x equals 10. Was it 10 or negative 10? It was 10. Okay. So we have the square root of 10 plus 6 equals the square root of 11 minus 10 minus 3. So square root of 16 is 4. Square root of 1 is 1. 1 minus 3 is not 4. Nope. Now let's try x equals negative 5. So we have the square root of negative 5 plus 6 and the square root of 11 minus negative 5 minus 3. So that would be the square root of 1, which is 1. and the square root of 16, which is 4. 4 minus 3 is 1. So yes, that works. So negative 5 works, and 10 was extraneous. Now for our last example, I have another one for you to practice that's just like the last one. So you can go ahead and pause the video and give it a try and then resume. But I will make one comment, and that is, if you ever have an equation, maybe that's like this, where you have two radicals, but they're on the same side of the equation, let's say, the first thing you want to do is rearrange it so that you have one radical on one side, one on the other side, and then proceed with the plan. It's going to be much easier that way. Okay, so we're going to square both sides. On the left, that means we're going to end up doing some FOILing. So I'm going to write out what we're about to do. And then on the right, it's just going to end up to be 6x plus 7. Okay, so for the FOILing, on the left, when we multiply the first, we get 2x plus 3. When we multiply the outsides and the insides and then add them together, we get 4 times the square root of 2x plus 3. And then when we do the last, we get 4. So let's keep the radical on its side, and then let's subtract 2x from both sides, and let's subtract 7 from both sides. Well, this one worked out kind of nice, actually, because we can divide both sides by 4 and make both sides much simpler, and then we're going to square again. Even if it wasn't an equation with square roots in it, anytime you're squaring both sides of an equation, you may be introducing extraneous solutions. So it's always something to go back and check. Okay, getting everything on one side, we have 0 equals x squared minus 2x minus 3. Let's factor that into x minus 3 times x plus 1. Set each factor equal to 0 and solve. And we get x equals 3 or x equals negative 1. Now let's check those. Excuse me. So we have the square root of 2 times 3 plus 2 equals the square root of 6 times 3 plus 7. So that would be the square root of 9 plus 2. That would be 3 plus 2, which is 5. And then on the other side, that would be the square root of 18 plus 7, which is square root 25, and that is 5. So x equals 3 works. Now let's check negative 1. The square root of 2 times negative 1 plus 3 plus 2 equals the square root of 6 times negative 1 plus 7. So that would be the square root of 1 plus 2, so that's 3. And then on the other side, we have the square root of 1, which is 1. 3 is not equal to 1 as far as I know. So x equals negative 1 is extraneous, and our answer is x equals 3. Maybe you're not always going to get something extraneous. Or maybe sometimes you get both answers extraneous. I don't know. Let's just be open to the possibilities. Okay, here's your assignment. And the first set of problems is finding domain and range, like we did in the beginning. And the second set of problems is solving the equations. Thanks, everybody.